Oh my God. Okay. Oh, you're here. Okay. Sorry about that. I should share the audio and share. Okay. Now, I think you can hear this music piece. Dun, dun. And did you hear now?
Yeah, I did hear it. Yeah.
Okay. So, uh, oh, okay. Oh, before talking that, I must told you that uh, every load should have a certain energy distribution over the frequency domain. Since I'm a fool to the music. Actually, I don't need. For some music knowledge, I don't have much of it. Okay, so I just firstly for the part two, you will listen to this Yankee music, and for example, let me see for the Yankee. Wait a moment. Yankee. Yankees hair music plot FS. Okay. Oh, yeah. It's Yankee music. For the Yankee part, okay. So for the Yankee part, actually there are it has 27 notes. So this is the Yankee piece waveform. Actually, it's just a wave, and since the frequency is high, so if we zoom in, this part, you can see it actually it's a wave. However, for each note, it has a certain frequency. Yeah, if we look into this here, the Yankee is just a function. Here we look into certain this function, and you can see there are. This is about some basic knowledge of the music. And I think you can find it in the introduction part. Since I don't have this basic knowledge, maybe, but it's understandable to me, and I think it will also be understandable to you. Okay. I mean, okay. So now, so here is the music, and for each, it's a combination of 20 notes. 20 notes for each note. For each note, it has a certain frequency. For example, for the first note, it has the frequency of C. Has C here is defined as this. So you can see for you can look into the comment part. It says C has the frequency of 200 and 61.63 hertz. So if we look into if we use if we use our frequency representation and to look into the energy distribution of the first lot, we can find so sorry. So since C is the 261.63, so it which means it should which means the energy should be concentrated on 261 hertz. We check it, and you can see, yeah, the energy is concentrated on the 261 hertz. So, so yeah, I think so yeah, for your question, I think for each load, if we look into the frequency representation, they each load will have a certain energy distribution over frequency domain. So, but however, I think however, to extract the circuits, to extract the loads from the circuit space, I don't think you should use the frequency representation to extract loads. I think you can just use that pattern and to extract loads, since every loads have a certain pattern like this. It has a sudden rise and then a decay of magnitude. I think this will help you to extract the loads. But this pattern is not available for every music piece, since if you look into Beethoven's time representation, it will show a different load pattern. I can show you this part. For example, for the Beethoven, where is Beethoven? Beethoven. I firstly. Okay, I have. Dun 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 dun. Beethoven FS. Dun 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 dun. Oh, wait a moment. It outputs some errors. Use the function or app. What's wrong? Oh, what's wrong? Wait a moment. Yeah. Did you hear that?
Yeah.
Okay. So actually you can see for the Beethoven's piece, the pattern is not is different. But however, for each note, actually there are 4 notes, or there are 8 notes. You can see for each note there are a sudden rise, and then there are decay. Of course, it's not a decay for the Beethoven case, but you can see the magnitude has been decreasing. in this lot. So so yeah, I think however you when you check for example, when you check every lot, it will not for the frequency representation, there should a combine of energy over the frequency domain rather than a single energy, rather than a single energy. For example, you will see some complex load. Their energy distribution will be like this. Which means for this node, it will has multiple energy which are located on different frequency area. So of course, in this lab, you don't need to answer why the energy is located on different frequency area. You just use the built-in function to show it, to show this energy distribution. That's all. This lab just want you to be familiar with frequency representation. Yeah, that's this lab, the lab 3 scope. Yeah. Oh, of course, for lab 3, and there are some tasks, some other tasks. I think we will talk about this later. For example, in this Friday's week, since I haven't for these tasks, for example, this task and this task, I haven't figured out how to do these tasks. We will cover these 2 tasks later. But firstly, I think you can try other examples and do practice to be familiar with frequency representation. Okay. Hi, Mandy. Did I answer your question?
Yeah, I think so.
Okay. Since, yeah. Okay. Okay. Now I think today's class is over, and if you have some questions, you can ask. And if you want to stay here to finish your homework tasks, you can just stay here. Yeah. Okay.
I think I'll just email you if I have any questions. Thank you very much for today.
Okay. Thank you.
Yeah, thank you. Bye.
Bye.